Okay, let's just jump right in. Outer space is so hot right now. I mean, you've got NASA's Artemis missions getting ready to push humanity further than we've ever been. You've got SpaceX building its giant Starship to go to other planets. We are getting really, really good at the engineering, the rocket science of getting to places like Mars. But in all this incredible, meticulous planning, what's the one critical, deeply human thing that we've almost completely ignored? And no, it's not better radiation shielding or a new way to grow food. It's something much more fundamental, something at the very core of who we are.
Yep, our love lives. We are literally designing interplanetary vehicles, but we have barely scratched the surface of intimacy, relationships, and, reproduction in space. And as it turns out, the stakes are way, way higher than you might think.
So let's talk about that personal frontier. Think about this. We've been sending humans into space for over 60 years. We've had people living continuously on the International Space Station since the year 2000. And yet, in all that time, officially, sex has never happened in space. It's a frontier we just haven't crossed.
Now, check out that 1992 date, because this story is kind of wild. That's when astronauts Mark Lee and Jan Davis went up on the Space Shuttle Endeavour as newlyweds. They'd secretly gotten married and didn't tell NASA until just before the launch. The speculation was, of course, everywhere, but NASA has remained completely silent on the topic. So as far as the official record goes, the 250-mile high club is still waiting for its first members.
So why is this so difficult? I mean, really, before we even get to the complicated biology, we have to talk about the simple, straightforward physics of what some people have cheekily called the human docking maneuver.
Well, first, there's basically zero privacy. The ISS might be the size of a football field, but it's a workplace, and the walls are thin. But the bigger problem, the real showstopper, is physics. Newton's third law, right? For every action, there's an equal and opposite reaction. Here on Earth, gravity and friction hold you down. In zero-G, any little push sends you floating away from each other. Just staying together becomes a serious logistical problem. Now, trying to solve this problem has led to some, well, let's call them creative solutions. People have actually designed things like the two-suit, which is pretty much exactly what it sounds like, and, get this, the Snuggle Tunnel, which is an inflatable tube meant to provide some stability. And this isn't just theory. Some of these concepts have actually been tested for a few seconds at a time on those parabolic flights, the vomit comets. But okay, let's just say we solve the physics, we get the harnesses and tunnels all worked out. Well, that's when we run into a whole new set of much bigger hurdles: biology. This is where we move past the mechanics of it all and into the potential consequences. And this is an area where we have shockingly little data. So far, the only species that has ever gone through a complete reproductive cycle in space, from conception to birth, is the Japanese rice fish, a fish. When it comes to mammals, the data we have is, well, it's concerning. Back in the day, a Soviet experiment sent pregnant rats to space. Most gave birth successfully, which is good. But one of the mothers died from what scientists believe was just the sheer stress of spaceflight. That's not exactly a confidence booster for future Martian parents, is it? And this brings us to an even bigger, more profound idea. Let's forget about the parents for a second. What about the child? What would it actually mean to be born, to grow up, in an environment that is fundamentally, biologically, not Earth? This leads to a really mind-bending question. Even if a child is born perfectly healthy on Mars, could they ever visit the planet where their parents came from? Could they ever see Earth? All the science we have right now points to a pretty stark answer. Probably not. Ever. And why is that? Well, a skeleton that develops in low gravity would almost certainly be weaker, more brittle. It might not be able to handle Earth's strong gravitational pull. But beyond that, think about their immune system. Growing up in a relatively sterile Martian habitat, they'd have no exposure to Earth's countless microbes. A simple trip here, a simple cold, could be fatal. Earth would literally be toxic to a Martian-born human. And this is the number that changes everything. 1/3. That's the force of gravity on Mars compared to Earth. A child born there would have their entire biology, their bones, their muscles, their heart, shaped by that reality. It would effectively make them a native of the red planet, and potentially trap them there for life. So, what happens when you have a population of human beings permanently separated from Earth by millions and millions of miles? This is where the whole conversation gets really, really big. This is where we start talking about the future of human evolution itself. Forget the physical challenges for a moment and just think about the communication. When Earth and Mars are closest, there's a 3-minute time lag. When they're farthest apart, it's 22 minutes. One way. That means a real-time conversation, a simple video call with your family, is physically impossible. You'd be sending messages back and forth. How do you maintain a relationship across that cosmic divide? This all leads to the ultimate question. What happens if interplanetary relationships become not just impractical, but maybe biologically dangerous or even impossible? What happens when you have two groups of humans that stop mixing their genes? There's this quote from the research that just says it all. In biology, the constant exchange of genes is what holds a species together. It's the glue. When you isolate two populations and you prevent them from interbreeding, they will, inevitably, start to drift apart.
And there's a scientific term for this. It's called speciation. It's the engine of evolution. It's how we got the incredible diversity of life on our planet. By creating a permanent, isolated human settlement on another world, we could be unintentionally kicking off the process of human speciation. We'd be starting the clock. So as we reach for the stars, as we build these amazing machines to take us there, we have to ask ourselves, are we actually prepared for the possibility that we're about to create a new branch of humanity? A branch that can never come home? It seems the entire future of our species might just depend on how we figure out how to manage the ultimate long-distance relationship.